Assalamu alaikum students. Today we are going to discuss infinite geometric series. We have already discussed about some of a few number of terms in the previous session. Today we are going to discuss that what will happen if the number of terms goes to infinite. We still remember that we have the formula for the n geometric series, n number of terms, that was equals to 1 minus r power n over 1 minus r. This was applicable to the number of terms like 5, 10, 20, 100 and up to so on when the number of terms are given to you. But what if that when n reaches to infinity, what's going to happen in that case? Then we simply write, this is just to make a generalized rule for infinite number of geometric terms. When n tends to infinity, S infinite is going to be a into 1 minus r power infinite over 1 minus r. As we know, in infinite geometric series, r is less than 1. And we know when a number is less than 1, when we take higher powers, the number is going to be reduced and reduced and reduced. Just like we take an example like this, if it is 0.1 power 2, it's going to be 0.01. If it is 0.1 power 3, it's going to be 0.001. If it is 0.1 power 4, it's going to be 0.000 and 1. Now you see here, as the number is increasing over here in the power, the number of zeros are increasing over here. First time it was 1 0, then 2 zeros, then 3 zeros, and up to so on. When this reaches to infinity, there are infinite number of zeros, and we assume that when n approaches to infinity, this r power n, it goes to 0. Because as many number of zeros are there, that this number will become negligible. So when this will reach to 0, that actually means r power infinite is equals to 0. So by placing it over here, we reach a conclusion that r s infinity is equals to a into 1 minus 0 over 1 minus r, which will take us to a place to find out that this is a rule to find infinite number of terms sum in geometric progression is S infinity is equals to 1 minus R. But this formula is normally given to you in the data booklet. You don't have to prove this. This is just for your general knowledge that how do we get it. We will just utilize it. Let us take an example over here in which he may be asking you to find out the sum of infinite number of terms. Find the sum to infinity of each of the following sequences in which 1, 0.1, 0.01 and 0.001. This is an example. Here, this is 1 plus 0.1 plus 0.01 plus 0.001 and up to so on, and it goes to infinity. Now here we see a is equals to 1, and the value of the common ratio in the geometric progression or geometric series, we can find it by using second term divided by the first term, or third term divided by the second term, or ratio of any consecutive terms. So this is going to be 0.1. So if you are looking for the sum to infinite number of terms, S infinity is going to be a over 1 minus r, which is 1 over 1 minus 0.1, which becomes 1 divided by 0.9. And obviously 1 divided by 0.9 gives you 10 over 9. Now this is a way out when we can find that the sum of infinite number of terms gives us a value which is a specific number. But in this case we see that r, the value of r is always less than 1, because if we increase, like more than 1 is there, then obviously when this number is more than 1, this will go to infinity and will not be able to find out a specific number. So that sequence is going to be considered as a divergent sequence. Whereas this is a convergent series. Convergent means it takes you to a certain specific number. And this is also helpful to us when we are looking for recurring decimals. Recurring decimals. For example, when we have 0.3 bar, this actually means 0.33333 and up to so on. And we can write it in this way: 0.3 plus 0.03 plus 0.003 and up to so on. And we can find out the sum of this infinite geometric series, in which a is equals to 0.3 and r is going to be 0.03 over 0.3, which gives us 0.1. And if we look for s infinity, a over 1 minus r, a is 0.3 over 1 minus 0.1, which is 0.3 over 0.9, and this gives us 3 over 9, which takes us to 1 over 3. And we have seen in our junior classes that whenever this is consecutively appearing 3, 3, 3, we can write it 3 over 9. But this is the basic procedure behind this, that how do we write it down. So the infinite geometric series sum helps us to find out that how to convert a recurring decimal into a rational number. Let us take another example which may help you a little bit more. Like a word problem is there. The word problem says that the third term of a geometric progression is 16. The third term of a geometric progression is 16. And sixth term is minus 1 over 4. This is the information given to us. He is asking us to find the common ratio that means R and first term, that means A. And in the second part he is asking what is sum to infinity. Let us say this. We know an equals to ar power n minus 1, so a3 is equals to ar square. So it means 16 is equals to ar square. Let us say this is the first value. Now a6 is equals to ar power 5. So minus 1 over 4 is equals to ar power 5. Now by simplifying these two simultaneously, we will be able to get the value of a and r. If I find the value of a from here, what do I get? 16 over r square. Let us place it over there. Minus 1 over 4, 16 over r square into r power 5. When you simplify it, this becomes r cube. Now, r cube is going to be minus 1 over 4 into 16. This 16 will come down. So r cube is equals to minus 1 over 64. And r is going to be minus 1 over 4 by taking the cube root of this. So once we have found the value of r, which is the common ratio here, we can find the value of a as well by placing over here 16 over minus 1 over 4 power 2. So this is 16 over 1 over 16. And this 16 goes up there, 16 into 16, it's going to be 256. So we have found the first value, we have found the common ratio. Now we can easily utilize this to find out the sum of infinite number of terms by using this formula. Now for the B part, we'll be going to this formula. By placing the value of A and R, this will help us to write down the sum of infinite number of terms. A is 256 divided by 1 minus R is minus 1 by 4. So it is 256 1 plus 1 over 4. So it is 256 divided by 5 over 4. And this will take you to 256 multiplied by 4 divided by 5, and you can calculate it with the help of the calculator. In this way, you can find out the value of R, the value of A, and sum to infinity. And this will be utilized in many A-levels questions. I hope this small session will be helpful for you to understand infinite geometric series, sum of infinite geometric series, and how do we utilize them according to the given conditions. Thank you.